Now, in the coming question, he is asking you to answer all the questions. This is section C, and as you know, this paper includes 3 sections. The alkaline compounds tres hydroxymethyl amino methane, known as a tres, is used to make a buffer biological research. He's asking you to sketch the low resolution protons in MR spectrum, and you can return back to the data booklet. If you return back to the data booklet, you will find that there are 3 different environments. This is the first one, and those are identical. So 1, 2, 2, and we have there 3, and this is a 3, and as you can see, 1, 2, this is 2, 1, 2, and this is a 3 because they are identical. Sorry, this is 2 and this is a 3. Let me repeat that. Okay, here we have 3 different environments, 1, and those are 2, and here we have the third. The ratio between the structures, this is also 3, this is also 3. You can find 6 to 3, can find 6 to 3 to 2. That's the point. Now, for the data booklet, you will find the chemical charts, or the part per million for the first structure, CH2, is around 1 for the first. So at 1 we have around 3, 4. This is besides the 2, so you will find it is like that. It's around 3, 1. Okay, wait. So it will be 6 to 3. It is around 1, 2, 3, 4. 1, 2, 3, 4. Okay. 4, and here we have 5, 6. Okay, that's one line. Then you will find the other like that. It's 4, 3. It's around 2, sides 2, and we have at 1 only 2 hydrogen. So for one chemical shift, and this is for you can find the data booklet between the amino group. It's for this one for the amino group, and this one is for alcohol, and this is for the CH2, since it is beside the alcoholic, or that's what we have. You should return back to the data booklet and find the answer and find the values of the chemical shifts. Now, for this reaction, Tris is a Prancer-Lowry base, and its conjugate acid is formed as shown. Now, he is explaining why the mixture of Tris and its conjugate acid act as a buffer solution when a smaller amount of the acid is added. Okay, here you will find that if the acid is added, a small amount of the hydrogen is added, the base and conjugate acid as present in a high concentration. So the ratio for the base acid to the acid only changed very slightly, and the pH was changed very slightly. So when trace acid accepts small amount of H plus and the base and conjugate acid are present in high concentration, the ratio which is the concentration of base to the acid is changed very slightly. That's why the pH does not changed a lot, or it's changed slightly. Okay? Now, write the expression for the Ka of the conjugate trace. So we'll see that's the conjugate. So Ka will be, when this decomposes, so it will give us the C4H11NO times the concentration of hydrogen over the concentration of C4H12NO3 positive. That's the expression. Okay. Now, for the coming idea, since the question is about the buffer, when hydrochloric acid is added to the trace, the acid salt is formed. The acid salt is solid, which has the formula C4H12NO3Cl and contains the conjugate acid of a trace. When 100 grams of the acid salt is mixed with 500 cubic centimeter of 0.2 mole of a trace, the alkaline buffer is formed. Calculate the pH of this buffer, assuming that there are no change in the volume when the solid is added. Ka for this reaction. Here we can use directly this equation where pH equals the pKa plus the logarithm to the power 10 of the acid over the the base over the acid. Now, when you apply this equation, you find that on the calculator, so it is 8.75, like negative log Ka, this one, and this is a plus the logarithm of, because you have 5 marks, the logarithm of A minus, it is found by the what is given in the question, and this is between brackets, sorry, and this will be 1.2698. This is calculated how? By First of all, you can find 100 grams, the number of moles, the mass over the molar mass, which is 157.5. That's the molar mass. You find the moles, and the moles is around 0.6349. Then you divide over the volume. So to find the concentration, it's 0.6349 over 0.5, and this will give you 1.2698 moles per cubic decimeter, and then you substitute there, and the final answer will be for the pH. It is 7 point, sorry, it's 7.27 since it is around the neutral, and this shows that there is no a lot of change in the pH value, or it's close to the neutral. Now, what's coming next after that? Okay. Is a solution of chloroethanoic acid is prepared for the titration of stress, and we have 0.015 grams of chloroethanoic acid, and its MR is given, dissolved in this volume, which is 1,500 cubic centimeter distilled water. The resulting solution has the pH of 3.42. Calculate the Ka for chloroethanoic acid. Okay, you can write the expression for the chloroethanoic acid. You will see it's like that. We have CH3, CH, for example, CH2. It's chloro, so one of them is, for example, CHCl, and this is COO. It's chloroethanoic, sorry. So we have two carbons, so it will be like that. Cl, CH2, COOH, and it is decomposed like that. Cl, CH2, COO, negative plus H plus. That's it. And here we have AQ, and it's a weak acid. Now, to find H concentration, or to find the expression for the Ka for this equilibrium equals the concentration of H plus times the concentration of ClCH2 COO negative over the concentration of the acid. Okay, and we can find the concentration of hydrogen. We can find the concentration of hydrogen like that. The concentration of hydrogen equals the 10 to the power negative pH, which is how much? It is 10 to the power, it's 10 to the power negative 3.42, and this will give us the answer of 3.802 times 10 to the power negative 4. And we can find the concentration by finding the number of moles over by dividing the mass over the molar mass, then over the volume. This is the concentration of the acid, and we consider those are equal. Then you apply the formula like that. The formula is applied and we will find Ka equals the H plus concentration squared over the acid concentration, and this will give you around 1.37 times 10 to the power negative 3. For the coming questions, just give me a moment. A titration curve of the thrice chloroethanoic acid is shown, as you can see, and then he explained how the graph shows its conjugate acid. Since if we return back to the curve, you will find this area between this kind, there is no lot of change in the pH value. This means that it's a buffer solution. And use the graph to estimate the pH of the salt form when stress is neutralized with chloroethanoic acid. You will find that from the middle of the curve, from the middle of where the curve is there, so it's around 6. And the last question is, he's asking you, suggest the reason why the buffer are so important. We have a lot of importance for the buffer solution, like it's important for the enzyme function, or it will preserve the acidity of the blood. And if you return to the marxism, you will find a lot of different answers. Please try to memorize them. Thank you for good listening. That's me, Bishr Samhan, chemistry teacher in platform MetaStars.